second experiment is interfacing LDR sensor with the Arduino board. This is LDR sensor. So this is the module for LDR sensor and we are using Arduino Uno board. So connections for this, here you can see this is LDR sensor which is having 2 pins. One pin you are connecting it to the 5 volts voltage and another pin you are connecting it to any of the analog signal pin A0 to A5. In the board you have A0 to A5. So I am choosing A0 to connect it. Next you are connecting the LED. LED you are having 2 pins. One you are going to connect to any of the digital pin and another leg of LED you are going to connect it to the ground. So these are the connections. So first I am connecting 5 volts to 5 volts in the Arduino board. Here you can see you are having V in pin, 2 ground pins. After 2 ground pins you will see 5 volts. So I am connecting 5 volts of Arduino board to the 5 volts of LED module. Next is connecting the A0 pin. A0 is analog signal pins here. So you are connecting A0. A0 pin to analog pin. A0 I am selecting. That's why here also on the board I am connecting it to A0. So if you are choosing A1, then you have to connect this to A1. I am selecting A0. Next you are connecting the LED connections. LED connections, one is for the digital pin. So this also again depends what is the pin number you are writing in the program. So I have written 9 pin. For this LDR we should choose PWM pins. PWM pins means the number beside the number in the Arduino board you will see tilde symbols. So here 9, 10, 11 are PWM pins. So I have chosen 9th PWM pin. So that's why I am connecting it to 9. LED output LED I am connecting it to 9th pin, digital pin, that is PWM pin. And next is the ground connection of LED. So you can choose any of the ground connection here. 14th pin, 8, 9, 10, 11, 12, 13, 14. 14th pin will be a ground pin. So these are the connections. So one LDR, leg of one LDR you are connecting to analog signal, another leg of LDR you are connecting to 5 volts. In the same way for LED, 2 legs, one leg is for ground, another leg is for digital pin. So what are the pin number you are writing, it depends upon the program. So in the program we have seen int LDR is equal to A0. A0 is the analog signal pin. Int value is equal to 0. First I am giving the value as 0. Next it will take according to the threshold value. So here we are doing serial communication. That's why we are given serial dot begin with the baud rate 9600. And pin mode 9 comma output. 9 is the LED pin that I have chosen. Pulse width modulation pin, PWM pin as an output. In the and void loop you are writing the actual program where whatever the value is collected by the LDR, I am storing it in the variable value and then saying it as serial.println. Whatever the value I am getting it from the sensor, you can see it on the serial monitor. In the same way, what is the value you are getting and how the LDR is related to the LED is depending upon the threshold value what you are taking. So here I am taking the condition as if value greater than 200. If the value is greater than 200, that is LDR value greater than 200, then you will say digital print high. High means LED will glow. And if it is less than 200, then LED will be glowing off. So for this I am connecting the Arduino board. So this is the final connection. After connecting, here you need to again say verify and upload. So what are the program you have written? In order to check whether there are any errors, first I am telling verify. So you can see in this board, if you are having any errors, it will show it here. Otherwise it will say success. Then you need to say upload. Next say upload. Before that, every time for every experiment you need to check whether it is connected to the Arduino board, whether board is connected to Arduino board and this port is connected to the port Arduino Uno or not. First this is the prerequisite before compiling the program. After selecting that, you say compile and upload. So after uploading it completely, after saying done uploading, you can see LDR will work. The functionality of LDR is, if there is dark, then LED will glow brighter. If there is light on the LDR, then it will be off. If I close it, there is darkness on the LDR sensor, so the light will glow. If I remove this, if there is more light on the LDR sensor, then the LED will be off. If I am putting again darkness here, then LED will glow. So LDR sensor is a light resistance sensor, light detecting resistance sensor. That's why it will work fine when it is dark.